Welcome, Professor Gregg Semenza. Thank you for the privilege of planning this interview. Your Nobel Prize is connected with the groundbreaking discovery of the HIF-1 protein, how it's related with changes in oxygen availability in human beings.
Yeah, as you know, oxygen is critical for our survival. It's the thing we can do without for the least period of time. And so there are a whole series of different systems that are designed to ensure that every cell in the body gets adequate oxygen at every moment of your life. And the hypoxia-inducible factors play a role in guiding these responses. So, for example, if you have blood loss or you go to high altitude, the cells in your body will not receive adequate oxygen. And cells in the kidney will produce a hormone called erythropoietin, or EPO, which stimulates red blood cell production. And of course, the red blood cells carry oxygen to the cells. So the production of more red cells corrects the hypoxia, and the system returns back to normal. And we first discovered HIF-1 by trying to understand how the production of EPO was regulated by oxygen availability. And we found a short sequence in the gene that controlled this response. And in fact, we could take this sequence out of the EPO gene, put it into a different gene, and we could make that gene become expressed under hypoxic conditions. And then we used that sequence to identify the protein HIF-1. And we found that this protein is very sensitive to oxygen levels in a very interesting way. When oxygen levels are normal, an oxygen atom gets inserted into the protein, and this is a signal to destroy the protein. When oxygen levels are low, that doesn't occur, and the protein can rapidly accumulate in your cells. So it's a beautiful system to directly change the any loss of oxygen levels to an increase in the expression of HIF-1, which then in turn turns on responses like the production of EPO that increase oxygen delivery to the cells.